Hey everybody, welcome back to the video tutorial on Python OpenCV, fishing bot for World of Warcraft. So yesterday I made a small mistake. I was getting all excited because our bot was starting to work. So in our time.sleep function, I had said that this was 5 milliseconds, which was kind of what I wanted, which would equate to around 30 frames per second. And I put a 5 in there because I was thinking about OpenCV's wait key. But time.sleep is in seconds, so if we want to use this function as our sleep function, we need to set that to the correct value. So I'll just show you. If I leave this at 5 and I keep this FPS line on, if we run our agent, we're only going to be getting about 0.2 seconds, 0.2 frames per second. So there it is, 0.19. So it's way too slow for what we're trying to do. It does work. In our case, it was working yesterday because we weren't really fishing with it, but we got to fix this. So this is an easy fix. Let's set this to about 0.005. That's 5 milliseconds. Let's run. And we should see around 30 frames per second. Looking good. So I'll quit that. Cool. And then the other thing that I really want to do is I want to keep this FPS on the screen. I think it's a useful thing. So let's create a variable. Let's call this FPS report delay. Let's set that to around 5 seconds or so that it's not spamming the screen, just constantly filling it up like that. We want to be able to see other reports. And then we'll have, we'll call this like FPS report time equal to time.time. So we're going to store two time variables here. One is going to be for each loop's time iteration, and the other one's going to be for this FPS report time. So we can use those in the future if we want to use those. And what we'll do is we'll just say if time.time minus our FPS report time equals or is greater than or equal to our FPS report delay. So if it's been longer than 5 seconds, let's print this out. And then we'll, oops. Hit the wrong key, and then we'll store this as a variable too. We really don't need both of these, but I'm just going to keep them in there for now. Oh. Accidentally hit something. Let me close my terminal. Let's try to run this. All right. So this thread's going to start, and then it should give us an FPS report about every 5 seconds or so. If we did it right. Looks like we didn't. Let's see what's wrong. Oh, this is the problem. We want our FPS report delay to only update inside of the if statement. Otherwise, it's always going to update and it will never exceed. It will never increase enough to trigger. So let's fix that. So now we should get around a 5-second delay. There it is. So we're getting around 30 frames per second, and now we can monitor that without constantly spamming the console. Okay, just a little housekeeping stuff. So let's go back to our phishing agent, the fun stuff. So yesterday, if you remember, we were able to start up this agent, have it cast, and then I've been having this issue and I've been testing it. It seems like it has something to do with my screen capture at the same time making this video as running this. It seems like there's some conflict there. So I'd be curious if anybody else is having this issue. I can't get the issue to happen when I'm not saving a video. So I think that's the problem. I've tested it a lot, but you can see the agent's working quite well. So we're getting the hand on the bobber, which is what we want. All right, so I'm gonna kill this. Okay, so the next function that we want to implement today is our watch lure. So this is a little bit tricky. Watch lure is going to be our AI watching it, waiting for that bobber to move, and then it'll know, okay, now I got to click it. Because if you remember, if it clicks it early or late, it's not going to trigger as valid, and you're going to lose the fish. So how are we going to do that? So right now, we have our target, we have our fishing target asset, which is this guy. And if you look at the bobber, which is pretty standardized, you can see it's always got this shape. And what we can do is we can, right now it should be finding the target somewhere around here, because our target is this. It's this blue and red with this 45-degree line. So it's probably zooming in with a laser like right in this region, which is great. But when the bobber moves, we want to make sure if it moves a little bit or a lot, either way it's going to be able to trigger. If it's kind of in this fat spot here where it's pretty fat, the bobber might move a lot, but it might, if we were to put like a laser pointer on that, it might still look like it's on a feather if you were just looking at that 1 pixel. What we want to do is we want to have like a 1 pixel laser that is really fast. It's updating, it's looking at that pixel, and as soon as that pixel changes to a value outside of what we think is the threshold, depending on the zone, we want it to trigger. So you can almost think of it as like a laser. It's focused on this laser, and as that bobber is moving up and down, if it moves a little bit, that laser might still be on the feather, right, as this thing moves up and down. But when the bobber, let's say the bobber moves down enough, that laser ends up pointing between these two. It sees that green water, and that's the key, that the bobber moved a lot. That's how we're going to tackle this problem. Okay, so let's jump into our fishing agent and let's set up this laser pointer that I just described. So the first thing we're going to want to do is in our move to lure function, we're going to want to call watch to lure, and we're going to want to bring in this max location. This is the location that it identified. So we're going to call self.watch lure, and let's bring in that max location. That should be the location of our fishing bobber. And we have to add a parameter here so that it matches. Okay. So now we've got our max location for watch lure, and we need to create a laser pointer, if you will, like I said, which is going to be 1 pixel. We're just going to use 1 pixel for maximum speed, let's say. And what we're going to do is we're going to define a object pixel, and that's going to be equal to self.mainAgent.image_HSV. Is that what we called it? Or no, it's cur image HSV. So we want to make sure we're using the HSV version of the image, not the regular image. This method could work, but as I discussed previously, this is going to be easier, more effective. And then we don't want the whole image. What we want to do is we want to take a slice of that so we get just that 1 pixel. So we're going to use max location, and be careful on here. You want to use max location index 1 for this one, not 0, and max location 0. Okay, and then let's print this pixel. We can just see what it's going to look like for a moment, and then let's do this. Let's add a while loop, so that's going to keep updating. So it's going to continuously be watching that, which is what we want. So just over and over and over again, it's going to be looking at that pixel. In our case now, printing it out. And we don't want that to go on forever though, so let's do a watch time. We'll set that equal to time.time. And then what we'll do is we'll just say if time.time minus our watch time is greater than or equal to, we'll do 3 seconds just for now. Then we want to break this loop. So this is where you're going to want to add the functionality to catch a timeout situation. So while you're fishing, if this thing goes on and on and on and it doesn't get a hit, this is where you would put that timeout in. So you could almost call this fishing timeout. So 3 seconds is not long enough. It's probably going to be around 30 seconds, but this is where you want to break out of this loop if that thing doesn't register, if something happens. So let's run this and let's see how it looks. Okay, let's start. So we've got our main agent running. Let's start our fishing agent up. So you can see here that when it moves the mouse, it's going to pick up that target. Let me let it try to pick up the bobber. So it's casting, and we didn't get the bobber, we got this. But you can see that we have a hue, saturation, and value number. And if I move this around while it's on the target, oh, now it's on the bobber. So if I move this around, you can see that that's going to change live. So think of it like a laser pointer that it's constantly looking at the hue, saturation, value. And if this thing shakes, there we go, so 85. So if this thing shakes, you're going to see those numbers change. And if they change enough, that's the key that we're on the water. If they change if that thing bounces just a tiny bit, then it's hard for me to do it manually, but you know, that HSV number, see how it's 84, 85? That means it's kind of the same object. What we're looking for is when this image moves, or in our case, the real bobber moves, that HSV number is going to change enough, and that's going to say, yep, the bobber moved. That's our trigger. Okay, so you can probably see where we're going with this. So let's do this. Let's increase our wait time to 10 seconds here, just so that we have a little bit more time. And when we break out of this loop, even if it times out, in the case of this game, even if this times out, we still are going to want to pull the line, just because there's a chance that you'll have a fish on there. So, in some games, depending on the application, maybe there's a negative consequence for doing an action potentially, so you wouldn't want to do this. So, you got to use your judgment. But in this case, it doesn't hurt to always pull the line, even if it times out. And what we want to do is we want to implement, if you remember, we have like a Feralis day, Feralis night zone. So we just have hard-coded in one zone, just to kind of show an example of how this can work with different zones. But we're just going to go with that. So you would do something like this: if self.mainAgent.zone equals Feralis. So if we're in Feralis, and self.mainAgent.time equals night. So if we're in Feralis and it's nighttime, then we want to do this code, right? We're going to do what we want to do, and then we're going to break. This pass is just a placeholder. So we're going to do our code, and then we're going to break. And we probably want to do a print. We'll do print byte detected. Let's do that. Okay. But how does it know when the fish is going to bite? So what we got to do is we got to do one more check. We got to say if pixel 0. So we're looking at just that one value inside that HSV. We're looking at H. So if the H is greater than or equal to 60, and I've just done some playing with this to find the right value. Your mileage is going to vary depending on the image you have and that sort of thing. So you're just going to have to tune this. Once you get it tuned, though, it's going to be very predictable. So in this case, on the image that I have, if the pixel 0, which is Feralis, that's the Feralis zone, and I can't remember if that's day or night, but it doesn't matter. So if the pixel 0 is greater than 60, we'll print byte detected. We'll break this loop, and that'll cause us to do self.pullLine. And then, this is where we're going to execute our code in a minute. We'll say, pulling line, which doesn't do anything right now, but we can kind of see the flow here, the progression. So let's try this out. So let's start up the agent, and then let's start up our fishing thread. Okay. So it was on the wrong area, so that just ignore that. So let's let it run again. Okay, so it's casting. It moved to the bobber. Good. Okay. And if you notice, I'm not going to move it at all. It's just going to sit there. So it's waiting, it's waiting, it's waiting. And those numbers we see, that's iterative. So it's looking. Okay, it timed out. So it pulled the line anyways. Nice. So let's do it again. So I'll move the mouse off. Okay, so it's back on. Now I'm going to give it a little jiggle. And you can see bite detected. So just that tiny little jiggle, and it detected the bite. That's exactly the behavior we want. That means that in the game, it's going to sit there and it's going to wait. And once that bobber gets bit, it's going to detect it. It's going to pull the line, which is our code that we're about to implement. And you can probably see exactly where this is going. So let me kill this. Very cool. So you can probably already guess where we're going with this. We already did, PyAuto GUI stuff. So now we're just going to have to use PyAuto GUI to do a couple of mouse clicks. So the first thing we're going to want to do is we're going to want to, so in World of Warcraft, if you want to auto loot especially in vanilla WoW, you want to do shift. You want to do shift right click. If you just right click, it'll open. If you just right click in this game, it'll open like a loot window, and then you have to click on the loot. And that's more steps, and that's more work, and that's more chance of an error. So it makes sense to eliminate that if there's, if within the game there are shortcuts that you can automatically take advantage of. So that's half of the battle, is optimizing the gameplay and then building a bot on top of that optimized gameplay. So what we want to do is we want to auto loot, because that's going to remove a whole series of steps and chances of errors. So the first thing we're going to do is we're going to do pyauto_GUI.key down. So if you remember, key down is going to hold the key. We're going to pass in the shift key. Now this can be a little annoying. Just be careful, because if you run this code, you'll actually get your keys locked down. It can be a little bit annoying. So just make sure you think through it before you run your code. And then let's do a very small sleep. So we could either use CV or time.sleep. So we can do like a time.sleep. We could do like 5 milliseconds. So it's going to hold the shift key, and then we want to do a pyauto_GUI.click. Click is going to be the mouse click, and now we got to tell it what button to click. So we want to do button equals right. Oops, if I can type here. Okay, and then let's do another time.sleep, and when we right click, let's let it sleep for maybe let's do 100 milliseconds. We'll do 10 milliseconds. It doesn't have to be that long. And then let's do a pyauto_GUI.key up, and this is where we want to bring the shift key back up. Okay. So again, what's happening here is instead of doing a key press, which is like just pressing the key, it's like immediately pressing it and releasing it. We want to hold that shift key down. So this line of code is going to cause the operating system to hold the shift key down. It's going to have a small delay here, just because we want to make sure that these commands don't come in too close to each other. Otherwise, it might not emulate the correct behavior. Then we want pyauto_GUI to right click, which is the loot key in the case of this game. Again, these commands are generic. You could use this for your game, whatever the commands are. And then we want to release that key. So that's what we're going to do here. So let's give this a try. Okay, I'm going to save this and run this. Okay, let's open this up. Okay, it's on the bobber, looking good. I'll give it a little shake. And there you go. See, it right-clicked my mouse. I did not right-click the mouse there. So there you go. We got a fully functional bot. It's on the bobber. It's waiting, waiting, waiting. We can watch. I'll let it time out. Should still right-click. There you go. Right-clicked. I did not do that. Very cool. Very cool stuff. Okay. So that's pretty much it. I mean, we have a functional bot now. So what's left for you to do? Really, the only thing that would be left for you to do at this point to make this, let's say, production ready, if you want to call it that, would be to go back, go through the zones, figure out your trigger, your HSV trigger signals. Different zones might have different signals. Build in that logic, so that you can, so like when we start the agent, in my demo, you can set the zone, which, we didn't really implement that, but that's easy to do. So you can set a zone. You could add another key for, T, which could be like set the time, day, night, or whatnot. Or if you wanted to go fancy, there's other things you could do. You can, so in the game, just to give you guys some ideas, and if you're interested in this stuff, let me know. We can keep this, we can make this bot even more complex if you guys are interested in it. I'm happy to do that. But for example, we could have the bot automatically detect what time it is by using this symbol here. There's going to be a day or a night symbol. So that's number one. We could actually get that visually from the OpenCV. So that'd be cool. That'd be just like a person. And we could even take this one step further and get even crazier. The zone in the game can come from so in the top left corner, there's a map here, see that? And there's a text. This is Wild Wind Lake. So we could implement a screen. We could implement text recognition. We could pull that in. We could compare that against known locations. Choose the closest known location, which then maps to the zone. So we could make this. We could make the fishing module fully automated. It's able to look at the map, tell you where it is, know if it's day or night. It's able to. You could use keys to switch to the correct hotbar. It's going to press number 1, and then and now you have a fully automated fishing bot that all you got to do is put the character in this location and start the program. And I think the next layer to get even crazier is to start talking about automation on having your character log in and walk to water, identifying where the water is and getting it self-oriented. And that's something we can talk about if you guys are interested in it. We can work on an even more complex bot. So I think this is probably the end of the tutorials. Take a look at the GitHub repository. I have my my original mini project that I made. You can look at that. You can compare it with the code that we made. It's pretty close. I deviated a little bit, just because every time I do it, it's a little different, I guess. But make this your own. You can make modifications. Give me your comments. Give me your feedback of things that you're interested in. If you want to take this project farther, let me know. I'm happy to do that. And also, please, like this video, subscribe to my channel. That helps me out. I'd like to know if people are finding these topics interesting. If they are, I'll continue to produce content. So thanks again for following through this tutorial. I really had a fun time doing it. It was interesting. And enjoy. Have a great day. Bye.